This video is for 16.3 homework, so if you need help finding the mean absolute deviation, then be sure to follow along. So I'm going to tell you that I'm going to let you use a calculator today, okay? So if you don't have a calculator at home, if you just open up the internet, you can just search calculator, and here's calculator. So you can use calculator for today's assignment. So this tells us that a laboratory is studying brown anole lizards. Never heard of that word. Probably said it wrong. Which are native to Cuba and the Bahamas, but are an invasive species. Oh, this is just going perfect with our science right now, you guys. So they are an invasive species in the southern United States from Florida to Texas. So these are coming in and taking over in these places, ruining their ecosystem. So the length of 10 male lizards caught by researchers in Texas is shown here. So here's the lizard, and here's 10 of them that they caught as invasive species in Texas. So the first, we're going to calculate the mean, and then we're going to calculate the mean absolute deviation. So to find the mean, we want to add up these and get a sum or the total. And we know there's 10 of them, so we're going to add them all up, and then we're going to divide by 10. So that gives us the mean. So now the next thing we want to do is we need to make a list. So here's our numbers, and then we're going to discover their distance from the mean. So my first number is 17.9. You need to figure out how far away is 17.9 to the distance. And you're going to record that here. Then you'll take 20.3. How far away is 20.3 from the mean? So right here's, this is going to equal the mean. So we're taking 17.9. How far away is it from the mean? Whichever one is bigger. The number that we're looking at or the mean, that's when you put first and subtract. So we're finding the distance to that. So we're not looking at negatives. We're finding that absolute value of how far away is it. So then we'll look at 20.1. How far is the distance to get to 20.1? So we're recording all of these distances. So you need to go through every number, write down the number, write down how far away it is. Write down the number, write down how far away it is. So you'll do that 10 times for each lizard. Then we're going to add up all 10 of our distances. So add up your distances, and then we're just going to divide by 10. We're finding the average of the mean absolute deviation. So right, absolute is how far away they are from the mean. So deviate, again, means how do they differ from that number? Are they spread out? They're not consistent. Are they packed in? The number's really small. So that tells us, right, they're pretty consistently around that size. So if we're getting a larger number, we can see that there's lots of different lengths of these lizards. If our number is small when we finish this, that means they're pretty consistently around that size. Number 2 tells us that Professor Berger ran the 50-yard dash 4 times and recorded his times here. What is the mean absolute deviation? So first thing we want to do is find the mean. So we're going to add up these numbers, and he did it 4 times. So we're going to add them up and divide by 4. Then we're going to make our list. So the first time he did 6.8, then 5.9, 6.2, and 6.7. So tell me, how far away is the distance to the mean? So 6.8, how many does it take to get to the mean? 5.9, how much is it to the mean? 6.2, how much is it to the mean? So we're going to do that for all 4 distances. And then we add these up. And again, there's 4 of them. So we divide by 4. And that will tell us, is he consistent with his running, or is he kind of all over the place? We can't really count on him. So go ahead and figure that out. Again, you can use a calculator for today. So you're still going to have to record everything to keep track of it, though. Number 3 says that several 2-pound bags of yellow onions at the supermarket are measured to see how much they actually weigh. So here it is. And so they claim that they're 2.1 pounds of onions, right? As those machines are putting them in, they don't always work perfect. Or they say, close enough, like, right, this one's 1.9. We're not going to find an onion that's 0.2 pounds unless it's teeny, teeny, tiny, and nobody wants that. So close enough. So here are the weights of our bags of onions. So we have 1, 2, 3, 4, 5, 6, 7, 8 bags. So we need to find the mean and the mean absolute deviation. So first we'll add these up and divide by 8. Then once we have our means, we added them up, divided by how many bags is 8. Now we're looking for that mean absolute deviation. So we're going to make our list here. The first bag is 2.1. How far away is 2.1 to the mean? Record your answer. We've got 1.9. How far away is 1.9 to the mean? 2.3. How far away is 2.3 to the mean? So do that for all 8 bags. And then we're going to take all the distances. We're going to add them up. We still have 8 bags, so we're still dividing by 8. Will tell us our mean absolute deviation. Is it consistent that you're getting about 2.1 pounds, or is there a larger mean absolute deviation? That means there's a lot of variety and you're not really getting your money's worth. Number 4 tells us that the mean is 9.4, and then the absolute deviation is 1.2. So we're going to list 3 data points that are within the mean absolute deviation. So we can take the mean, we can add the MAD, and then we can also take the mean and we can take away the MAD. So that will tell us, so here's our mean, and it will tell us the numbers that are bigger and smaller that fit within that mean absolute deviation, that are those consistent numbers. So this looks like we are taking 9.4 plus 1.2. And then we're going to take 9.4 and subtract 1.2. So any numbers that are within this range here are numbers that fit within our data set. So if they're outside of this, that means they're not really falling within the parameters of the data. They're kind of an outlier there. Number 4 says that the mean of a data set is 4.5. The mean absolute deviation is 8. So we're going to find the range, just like we did on the last problem, that describes where these can go in. So we're going to take the mean and we're going to add on the mean absolute deviation. We're going to find that upper range, and then we're going to do the opposite and subtract it to find that lower range. So mean plus the MAD, mean minus the MAD tells us that these numbers can go from here to here, and they're going to fall in that data set. Number 6 wants us to answer A and B. Oh, the prices of muesli cereal. I don't know what that is. If you do, let me know. Send me an email. I don't know what that is. So the prices of these cereal are at different stores here, shown in the table below. So we can see there are 1, 2, 3, 4, 5, 6 different boxes of this cereal from different stores. So first, what is their average price, the mean price? So if we add these all up, divide by how many boxes there are, that will tell us the mean. Then this one's kind of already in this table for us. So I'm just going to extend it. So now we can answer, so we need to find the difference here. So find the mean. How did I get from $5.09 to the mean? Right here. How did I get from $3.79 to the mean? So record for each box their distance to the mean. So how far do they deviate away from the mean, their absolute deviation? And then we're going to add them up and divide by 6 again, because there's still 6 boxes. Will tell us, is there a big, so right, if it's a bigger number, that's going to tell us there's a big difference in these boxes of cereal. You might want to be picky about where you get it from. Or if it's a smaller number, it's going to tell us that it's pretty consistent no matter where you go. So pick wherever this muesli cereal, you can get it wherever you want. You'll be paying about the same price as a different store. Number 7 says that the mean of the data set is 4.03, 4 300ths, and the mean absolute deviation is 2.69. So again, we're going to take the mean and add on the MAD, and then we want to take the mean and subtract the MAD to find that range and pick any numbers that fit within that range. So if it's bigger than the highest number or smaller than it, then that's not part of this absolute deviations. So it's not really a good fit for that set of data. Number 8 asks which is closest to the mean absolute deviation. So maybe which one is maybe rounded or so. First, we find the mean. So add these up and divide by how many there are. Then make a list and say this one is this far away. This one is this far away from the mean. How far away are they from the mean? Then add up your differences, the distances. Divide by how many there are. So which one is closest to that? So I do notice, right, this says 3.8, this is 3.9. The other ones are either, is it 1? Is it less than 1? So looking there. So add them up, divide by how many there are, find the difference to the mean, add up your distances, which one is closest when you divide. Number 9 wants the volume of a rectangular prism, length times width times height. So I can see it's using some fractions here. So we want to make those improper. So 3 times 2 is 6 plus 1 is 7 over 2 times 5.5. I'm going to let you do that one times 9 over 1. Multiply, multiply, and then simplify your answer. You can keep it in fractions since it gave it to you in fractions. Number 10, I believe this is the last one, says that Tyler collects data about many animal companions, dogs, cats, birds, etc., that live at each house in the neighborhood. So at the houses, there are 1, 0, 2, 3, 2, 4, 12, 1, 2, and 3 pets that people have. So we're going to find the mean, add them up, divide by how many there are. You're going to find the median. So put them in order and then find the middle. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So that tells me we're going to have 10 on this side, 5 on this side, 5 on this side. You're going to have 2 in the middle. You've got to add together and find the middle of. And then our mode is which one happens the most often. So once you've found each of those, take a look and see which one do you feel like best describes. So which measures of centers are mean, median, and mode. Which one describes the typical, so it doesn't say like all of them, it says which one describes the typical number of companions. So what is common to have in this neighborhood? Okay, so that is everything for our homework. So if you need any more help with the mean absolute deviation, let me know and we can set up a time to meet together.